Chemical equations are a way that we show how a chemical reaction is occurring. It's important for us to look at the way these are written so that we can look at them in a consistent way. In a chemical equation, we write the reactants on the left and the products on the right. So the reactants are the things that are reacting. The products are the things that are produced or made. You can also kind of think about a chemical reaction as a little bit of a story. This is what happens at the start. So the chemicals on the left are what you have at the start. The chemicals on the right are what you have at the end. Here are some common symbols that are used in chemical equations. A plus sign is used between different terms, so between different compounds or elements. It allows us to separate different components of the formula so we can see how many things are being combined or how many things are produced. The arrow is our reaction arrow. It tells us that everything on the left is reacting to form products. We'll talk about different types of arrows as we get later on in the course. There's also physical states that are shown by symbols. S is the symbol for solid. It's kept in parentheses, so we have the parentheses and then the lowercase s. L here, lowercase l in parentheses for a liquid, lowercase g in parentheses for gas. AQ here in parentheses, it designates that something is aqueous or dissolved in water. And that's going to be very important when we start looking at salts and acids and bases. And there's a variety of things that can sometimes be over your arrow or indicated around the arrow. In this case, this is a delta. It indicates that the reactants are heated, but there's a variety of different things that can be placed there to indicate that there are conditions that are happening that are required for a reaction to occur, but they aren't reactants or products. You can think about this as like a match or something that needs to be put into sunlight to react. The sunlight or the match aren't actually a reactant. They're not a product. They're just something, part of the conditions that are required for a reaction to occur. We also, in our reactions, have coefficients. So there are numbers that are placed in front of the formulas that tell us how many of that atom, molecule, compound, element, whatever it may be, you have in the formula. So in this case, we have 2 sodium atoms plus 1, and I'm going to put the 1 in here. We often drop the number 1 when we're writing these formulas. So 2 sodium atoms plus 1 molecule of chlorine gas forming 2 sodium chloride. So this indicates our ratio of molecules. And just think, how many molecules of sodium are needed to react with 1 molecule of chlorine gas. We also can count the number of atoms in or ions that are on each side of a balanced equation. So in an equation, I'm going to make like a little line here where the arrow is, because we want to look at everything that's on the left side of the arrow separate from everything that's on the right. So on the left side of this arrow, I have 2 sodium atoms. For the chlorides, I have 1 chloride. So the chlorine gas has 2 chlorines. So I have 2 chlorine atoms. If I look on the right, I have 2 NaCl's. So that means I literally have an NaCl and an NaCl. So I can see that I have 2 sodium atoms and I have 2 chlorine atoms. So see, we have 2 sodium on the left, 2 on the right, 2 chlorine, 2 chlorine. This helps us to look at this final concept, which is the law of conservation of matter. It's that matter cannot be created or destroyed in chemical reactions. It's essentially why our chemical equations must be balanced. We can't just get new sodium atoms out of nowhere. We can't get more chlorine atoms out of nowhere. We have to have the same number of each element on each side of the equation. And we'll take a lot more look at this when we talk about how we actually balance these equations.